Kia ora guys, we are going to have a look at rearranging equations. Rearranging equations. I'm going to give you guys the concept, how I do it, and I'm going to give an example for each exercise on this worksheet, which should help you be able to complete it. So, I like to use bed mass backwards. So usually it's bed mass, but we're going to go Sam Deb. So that's subtract, then add, then multiply, then divide, then, oopsies, exponents, then brackets. Now what we're going to do is we're going to do this order, but remember this order is for opposites. So that's what we're going to use it for. So we've got subtract is the opposite to add, multiply is the opposite to divide, then exponent has an opposite which is a root, and we're going to bear in mind that brackets are the last thing, but fractions always have secret brackets on the top and the bottom. So we're going to do order opposites. We are then going to make sure that both sides stay equal, and finally we are going to isolate something. Usually in these examples we're isolating x. So when we're rearranging equations, these are the things I am following. Okay, so my first example is similar to the questions in exercise 1. So we've got y equals 2x minus 3 over 5. So remember, if we've got a fraction, these are secretly in brackets. I'm actually going to draw these brackets because really they are there. Also that 5's in a brackets, but I mean it's just a singular number. So is there any subtraction? Yes there is, but it's in a bracket, so we're going to leave that for now. Addition? No. Multiplication? Yes, but it's inside a bracket. Is there division? Yes there is. So what's the opposite to division? It is multiplication. So we've got divide by 5, so we're going to do the opposite. We're going to times that by 5 if we want to get this x unpacked or isolated. So we need to make sure it's equal. So we've times by 5 on the right hand side, so we need to do the same on the left hand side so that it stays equal. So let's do that. 5 times y is 5y. Dividing by 5 and timesing by 5 are opposites, so they just cancel out. So we're left with 2x minus 3, and then that bracket's done with now. So let's follow our steps again. We are isolating this x. Is there any subtraction? Yes, there is. Let's do the opposite. So we are going to add 3 on this side. If we add 3 on the right hand side, we need to keep it equal, so we're going to add 3 on the left hand side as well. So on this side we're left with 5y plus 3. And on the right hand side, this minus 3 and this plus 3, they cancel out. So we're just left with 2x. So now we're trying to isolate x. So we've got times 2 attached to it. The opposite of timesing by 2 is dividing by 2. So we're going to divide by 2 here and divide by 2 here. So everything on the left hand side is getting divided by 2. So what we need to do is we need to make that into a fraction. 5y plus 3, a big division symbol, over 2, and then these cancel each other out, and we have successfully isolated x. X is now the subject of the expression. 5y plus 3 all over 2 equals x. So that's example 1 for exercise 1. Let's have a look at the next section. So in exercise 2, there are a lot of really wordy type questions. You're going to have to go and unpack them most of the time. I'm going to give you an example that will help you with exercise 6 as well. So we're going to actually go to the hardest example I'm going to give straight away. I think this is a really cool example, and that's why I like it. So we've got the volume of a sphere. So if we've got this, oh man, that's the worst sphere I've ever drawn in my life. Right, if we've got this sphere here, we can find on Google that the volume of a sphere is 4 over 3 pi r cubed. What we want to do here is I want to make R the subject. Make R the subject. So we're going to follow the same steps. Have we got any subtraction? No. Have we got addition? No. Have we got multiplication? Yes. All of these things are all being multiplied. We've actually got v equals 4 over 3 times pi times r cubed. So we're trying to isolate r here. So we want to get rid of that pi and we want to get rid of that 4 over 3. So let's start with the easiest one. Pi is just a number. It's this really long number, infinitely long in fact. So what we're going to do to get rid of a times pi is we can just divide it by pi, because it's just a number. So if we're dividing by pi on the right hand side, we're going to divide by pi on the left hand side as well. We'll keep our equal sign nice and centered. So here we're left with v over pi, and over here we're left with 4 over 3 times r cubed. So to get rid of 4 over 3, it's being multiplied here, we could divide by 4 over 3. But there's a really handy trick with fractions. It's called a reciprocal. And there's this cool thing that if you have, say, 4 over 3, and you times that by 3 over 4, which is the upside down version, you get, so we'd multiply on the top, 4 times 3 is 12, and then on the bottom, 3 times 4 is 12. Ooh, would you look at that? It equals 1. So fractions have this cool little thing where you can get rid of them real easy by just multiplying by the reciprocal. So let's do that. We'll times this side by the reciprocal, which is 3 over 4, and that will get rid of that 4 over 3, because it just makes it into 1. And then make sure both sides are equal. So we have 3 over 4 on this side as well. So we then have 3v on the top, and we have 4 pi on the bottom. And that these two things cancel because they're reciprocals. So that we are left with r cubed. Now, what's the opposite of an exponent? The opposite of an exponent is a root. Not necessarily a square root, because actually this time it's a cube root. So if we cube root this side, it will get rid of r cubed. So we have to keep it equal. So we're going to have to cube root that side as well. So that ends up being a really big cube root, 3v on top over 4 pi on the bottom. And these things cancel each other out. So then we've isolated r. Perfect. Now, one thing you may realize is that you get a really ugly left-hand side here. And you don't need to worry too much about that, because our focus is making r the subject. We don't really care how messy things get on the left. We could tidy it up later if it is too messy, but I think this is actually the best form that you can get, in my opinion. So that's an example that should help with 2 and 6. In fact, I think that is a question in part 6. So I'd like you to give that a go yourself anyway. So let's have a look at exercise 3. These are rational expressions. Rational expressions just mean we're dealing with fractions. So the example I've got for exercise 3. Oh, I need to make sure my camera's actually capturing that. Where are you? There you are. Cool. I was thinking of doing this one. It gets ugly. X minus 2 over x plus 3 equals 4y. Remember, we're trying to make x the subject. Now, you'll notice that there are 2 x's, and this happens from time to time, so we're going to have to be a little bit clever as to how we get rid of that. Because we've got x minus 2 on the top and x plus 3 on the bottom, we can't actually just divide that and do something nice to get x by itself here. So what I'm going to do is, because we've got, remember, fractions always have secret brackets. Because we've got a fraction, normally the best thing to do is make it not a fraction anymore. So best way to do that is multiply both sides by x plus 3. See, we've got divide by x plus 3, so let's just times both sides by x plus It did. How long ago did it chop out? Dang it. Okay. We know that if we've got, x plus 3 as our denominator, we can just multiply by x plus 3 and that will get rid of it. So that cancels with that. We've just got x minus 2 left on the left-hand side, but we've now brought an x over to the right-hand side. So let's expand this out first and then see what we can do. So x minus 2 will stay the same, 4xy, and then 4y times 3 is 12y. So we've got this x here, but it's attached with the 4 and the y, and we've got x over here. Let's get them together. So what I'm going to do is I'm going to minus 4xy off that side, and I have to keep it equal, so I'm going to have to minus 4xy on the left-hand side as well. So we're going to have x minus 4xy minus 2 equals, and these cancel, so we're just left with 12y on the right. This minus 2, don't really want him hanging around, so let's just get rid of it by doing the opposite. We'll plus 2, and then we'll plus 2 over here. So they'll cancel, so we get x minus 4xy. Notice that I try and keep my equal signs all in a line going down. That really helps with working out. 12y plus 2 on the right hand side. So now we've got our x's together, and I'm going to do a trick that you all know but you may not think to do quite yet. I'm going to factor out an x. So they both have an x, so we can factor out an x. X times 1 is x, minus x times negative 4y will get us minus 4xy. Perfect. So now I've got x by itself, finally. Took a bit of a process, but we got there. And now we can get rid of a bracket. So this is x times this bracket. So all we need to do is just divide by whatever is inside that bracket on this side. And we have to keep it equal by doing the same on the other side. So I'm going to need a little bit of space. Remember how I said things start getting a little bit ugly? This is a great example. 12y plus 2 all over, put it in a fraction. 1 minus 4y. So remember, the right hand side, it doesn't matter that it's ugly because there's no x's in it, and we've managed to make x the subject here. So that is example 3 for exercise 3. What about exercise 4? Let's get an example going for that. Exercise 4. So the difference with these ones is that you're dealing with a lot of roots. So I've got the most complicated root I could think of quickly. I got 2x minus 2 on the top and an x plus 3 on the bottom. I know that's going to be annoying for later, and that's why I picked it. So how do we get rid of a root? The opposite of a root is an exponent. If a root doesn't have a number up here, we can assume it's a square root. So the opposite of a square root is just squaring. So we'll just get y and square it. And then that will get rid of the root. 2x minus 2 was inside it, and at the bottom was x plus 3. Then we're just going to follow the same steps as I did in my example in question 3. But I'll do that for you. So I'm going to do a little less working this time, because this is what I would really show for my working. What I would normally do is I would just straight multiply by what's on the bottom of the fraction over there. And I'll do a little less working. That's not a divide. That's meant to be a minus. I just did a dot by mistake. Sorry. Do you see what I did then? I had x plus 3 on the bottom, so I just multiplied this side by x plus 3. And then it got rid of it. So once you get a little bit lazier, well, once you get quite good at it, you can do less working, but still show all of your working out, really. Okay, so let's expand here. Xy squared plus 3y squared equals 2x minus 2. Okay, I want all my x's on one side, so I'm going to have xy squared, look at this, a little less working, minus 2x, because I minus 2x off that side, and then that has plus 3y squared, so that's going to become negative 3y squared minus 2. So now I've got my x's together, so I can factorize factor out the x like I did before. So I factor that out, minus 2, y squared minus 2 equals 3y squared minus 2. Now, x is by itself. If I just divide by whatever this is inside this bracket, so I'm going to make a fraction over here, negative 3y squared minus 2 all over y squared minus 2. And that, I can't be bothered simplifying it any further, and I don't think it can be simplified any further. So let's have a look at our final example for today, which will help us with exercise 5. Remember, I showed you an example that will help with exercise 6 already. So this is the final example. We're going to go 4y squared equals 3x plus 2 squared minus 5y. Okay, so we'll do it a little bit slower. We want x to be isolated. We want that to be the subject of the formula. So let's unpack from as far out as we can. Look at this. SAMDEB, subtract. So let's get rid of that first. We do the opposite, so that's add. So we're just going to add that. Keep it equal, so we add the same to both sides. Keep the equal sign nice and centered. So we've got 4y squared plus 5y on this side. And then over here we have 3x plus 2 squared. Alright, so we're unpacking the x. We can't do the bracket, but we can do the exponent. So that's squared. So the opposite of that is if we just do a square root to both sides. So we're going to have a big square root 4y squared plus 5y equals, these things cancel each other out, so we've just got 3x plus 2. Okay, now we're back into easy mode. The opposite of plus 2 is going to be minus 2, and we're going to have to do the same to both sides. The minus 2 is going to have to be applied outside of the square root. Okay, and then we got 3x. Final thing to do is divide that by 3, and then we can just do a really big divide symbol over here, because we are a bit lazy. 4y squared plus 5y minus 2, and everything is being divided by 3. And that leaves us with just x, so there you go. So that has been rearranging equations. Remember, the steps I want you guys to try and follow are using SAMDEB for your order and finding opposites. Right? We need to make sure whatever we do to one side, we do to the other side as well. We need to keep both sides equal. And our goal is to isolate x, or in some cases, isolate y, or whatever it is. So, yeah, there you go. That's rearranging equations.